In this video, we are going to start new topic, maxima and minima. This is class 12 topic, and here we are going to learn this topic in detail. Okay, and this is very important topic in your class. So let me explain what is the meaning of maximum. Okay. Maximum. Suppose you are studying in a class and there are two sections, okay, section A and section B. So this is your class, section A, and in this class, suppose teacher is arranging a test for your subject, and students scored out of 30, some scored 25, some scored 26, some scored 29, okay. So in this case, some score 20, okay. So in this case, what is the maximum value? So maximum value is what? 29 within this section, okay. So we call this 29 as a maximum value, and lowest mark is what? 20. So we call this 20 as minimum marks, okay. Suppose there is another section B and student scored 19, 35, sorry, out of 30. So this is 30 and 18, 28, like this, okay. So in this section, maximum marks is what? 30, and least marks is what? 18, okay. Lowest marks is what? 18. So in this case, 18 is what? Your minimum marks, and 30 is what? Maximum marks, okay. Here 29 is what? Maximum marks, and this 20 is what? Your minimum marks, okay. So in this case, for this local section A, maximum marks is what? 29, and for this local section B, maximum marks is what? 30, and minimum is what? 18, and here minimum is what? 20, okay. So what if we combine this both the sections, section A and B? So what is the maximum marks scored by this class? So maximum is what? 30, and minimum marks including both the section, okay. So minimum marks is what? 18. So this is what? Maximum value and minimum value. We call this maximum value and minimum value, okay. There are one more term, maxima and minima. Maxima and minima. So maxima and minima is referred when there are multiple sections. Suppose here I have explained section A and section B, okay. This is class 11th or class 12th, section A and section B. So these two sections are having individual maximum and minimum value, different value, okay. Both the sections are having its own maximum value and own minimum value. So in this case, this section A, the value of maximum and minimum for section A is what? 29 and 20. So this 29 and 20 is what? Maxima value for this local section. We call this local maxima, okay. We add term local. So local, if we talk about local, so that value will belongs to particular section. So that is what? Local maxima and local minima. And if we find maximum and minimum value including all sections, so that is what? The maximum value and minimum value. And I hope you are getting. Good. So here we will define. So technically, maximum function is defined as, suppose there is a function fx, suppose there is a function fx be a real function defined on the interval a and b, then fx is said to have a maximum value in a and b if there exists a point c, in a and b such that if we are putting the value of A to B, okay, and we are taking point C. So if you are putting the value of C in that function, so the value of fx must be less than or equal to the value of fc. So in that case, that C point will be maximum value. Okay, this C point will be maximum value. We will understand this with the example. Suppose I am taking example, function f of x is equals to x square plus 5, okay, x square plus 5. So in this case, okay, I'll explain with the example, fx equal to x square plus 5. So in this case, variable term is what? X square. So always you take variable term. So x square is greater than equal to 5, sorry, equal to 0, okay. Variable term you equate with 0, okay. So in this case, by adding 5 both side, because in function 5 is there, that's why we are adding 5. So x square plus 5 is greater than equal to 0 plus 5. So this will be x square plus 5 is greater than equal to 5. And with this function, suppose we check the value, okay. So x equal 0, so 0 plus 5 greater than 5. So here 5 is equal to 5. X equal 1, so 1 plus 5 is greater than equal to 5. X equal 2, so 2 plus 5 is greater than equal to 5. So after solving, the 6 is greater than equal to 5, 7 is greater than equal to 5, okay. X equal 5 suppose we are putting, okay. So, oh sorry, x equal 2, so this will become 4, square is there, no? So 4 plus 9, okay. So if you are putting 5, so that will be what? 25 plus 5 is greater than equal to 5. So 30 is greater than equal to 5. Yes, all the conditions are true here, okay. All the conditions are true here. It means by seeing this, the least value is what? 5 only. So with this example, we can clearly see the minimum value of x is 5. So this x equal 5 is known as minimum value for this function. Let me explain one more example to clear this concept. Suppose your function is f of x 3x square plus 6x plus 8. X is subset of all real values, okay. So in this case, your function is 3x square plus 6x plus 8. So here we can take comma. So 3x square plus 6x plus what we can write this 8, we can write this as 3 plus 5, okay. 3 plus 5 is what? 8. So we take comma 3, so x square plus 2x plus 1 plus 5. So x square plus 2x plus 1 is nothing but 3x plus 1 whole square plus 5, okay. So here variable term is what? X plus 1 whole square. So we take this value 3x plus 1 whole square and we compare with the statement of inequality greater than equal to 0, okay. So 5 is there, so by adding 5 both side, by adding 5 both side, so 3x plus 1 square plus 5 is greater than equal to 0 plus 5. So here we can clearly see that 3x plus 1 square plus 5 is greater than equal to 5 only. So now we will check the value of x for this statement. So x equal 1, by putting x equal 1, x equal 1. So value will be 3, 1 plus 1 square plus 5 is greater than equal to 5. So this will be 3 into 2, 2 ka square 4 plus 5 greater than equal to 5. So 4 3 are 12, 12 and 5 17 is greater than equal to 5. This statement is true. X equal 1. Okay. Now if you put the value of x equal minus 1. So in this case 3 minus 1 plus 1 square plus 5 greater than equal to 5. So minus 1 plus 1 it will become 0. So this will be 5 is equals to 5. Okay, this is what 5 equals to 5. So with this example, if you are putting the x equal to minus 1, so this is what 5 equal to 5, a statement of equality we are getting. Okay. Now we will put one more value here to check our condition. Suppose we put x equal minus 2. So this will be 3 minus 2 plus 1 square plus 5 is greater than equal to 5. So 3 minus 2 it will become 1 plus 5 is greater than equal to 5. So 3 plus 5 8 is greater than equal to 5. Okay. So with these three values we can clearly see that the value of x equal minus 1 we are getting 5. Other all value we are getting what? Greater than 5 value. So in this case x equal minus 1 is what? Minimum value. This will be what? Minimum value. X equal minus 1 is what? Minimum value of this function. Okay. So we like this we have to find out the minimum value of the function, and here maximum value is not defined because x belongs to all real numbers. Okay, all real numbers, and in all the cases we are getting greater than 5 value. Okay, in the question it is mentioned x is what? Belongs to elements of R, real value. So we can find out here minimum value. Now we will see one more example where we will find the maximum value. So suppose your function is f of x is equals to minus mod x minus 1 plus 5 for all x belongs to real number. Okay. So variable term is what? X minus 1. So as usual जो हमारा concept है उसके according हम इसी को हम लेंगे x minus 1 mod is greater than equal to 0. Okay. So here mode value is there, and in function your minus sign is there. So we will multiply minus here. So minus mod x minus 1, and if we multiply minus sign, so this statement of inequality gets changed. So this will be what? Less than equal to 0, and this always हमेशा आप यह ध्यान रखिए जब भी आप माइनस साइन आप चेंज करोगे तो स्टेटमेंट ऑफ इनइक्वालिटी चेंज होगा. Okay, so in question 5 is there. So by adding 5 both side, so minus mod x minus 1 plus 5 is less than equal to 0 plus 5. So minus mod x minus 1 plus 5 is less than equal to 5. Okay, now put the value. So x equal, suppose you put 0, so this will be mod 0 minus 1 minus plus 5. So this will be minus 1 plus 5, so less than equal to 5. So 4 less than equal to 5. This statement is true. X equal 0. Now put the value x equal 1. So this will be minus 1 plus 5 less than equal to 0. So this is sorry 5. So 5 is less than equal to 5. So here the 5 equal 5. This statement is also true. Okay. Now put one more value. So x equal 2. So minus mod 2 minus 1 plus 5 less than equal to 5. So this value will be what? Here 1 minus 1, 4 less than equal to 5. So here, but with this examples, we can clearly say that x equal 1, if you are putting x equal 1, then we are getting value 5, and rest of all value of x we are getting less than 5, less than 5 only. So x equal 1 is maximum value here. X equal 1 is what? Maximum value. Okay. So x equal 1 we are putting, so what? 5 is what? Maximum value, and that domain will be what? X equal 1. That point is what? X equal 1. Understood? So like this we have to find out. So what will right answer? So 5 is the maximum value. 5 is the maximum value of f of x, where x is equals to 1. Okay, like this you have to write down your answer. Understood? I hope you are getting. And in this case, minimum value cannot be defined because x belongs to real numbers. Okay, so here we can find out only maximum value. Next example we will see. In this question we will find maximum value and also minimum value. Okay. So function f of x is equals to sine 3x plus 4 for all x belongs to all real value. Okay, real numbers. So we know the range of sine function is what? Is minus 1 to 1 only. Okay. So here variable term is what? Sine 3x. So we will take this. So minus 1 sine 3x is what? Greater than equal to minus 1 and less than equal to 1. This we will take. So here 4 is there. So by adding 4 both sides, so minus 1 plus 4 is less than equal to sine 3x, and sine 3x is less than equal to 1 plus 4. So in this case this will be 3 sine 3x and 5. Okay. So here in this case you have two value, one is 3 and one is 5. Okay, you got 3 value. So we will check the function for these two value, 3 and 5. So we will equate this sine 3x plus 4 equal to 3. So sine 3x is equals to 3 minus 4. So this will be sine 3x is equals to minus 1. So minus 1 is what? Pi by 2 only. Sine 3x is equals to minus sine pi by 2. So this sine and this sine get cancelled. So 3x is equals to pi by 2. Okay. So x is what here? Pi by 6. In this case x equal pi by 6. And for 5 we will check sine 3x plus 4 is equals to 5. So in this case sine 3x is equals to 5 minus 4. So sine 3x is equals to 1. Okay. So sine 3x is equals to sine pi by 2. So sine and sine get cancelled. So this will be 3x is equals to pi by 2. So x is equals to pi by 6. So see. So the value of x is what here? Minus pi by 6 and here plus pi by 6. So minimum value minimum value is what? 3 at x is equals to minus pi by 6, and maximum value is 5 at x equal plus pi by 6. So, this is what your minimum value and this is what your maximum value. This is the answer. So, like this you have to solve your